Hello everyone, this is Debao Dynamic Design. I am going to record a complete set of teaching videos about the fluid module added in Cort 1000, 25.3. A complete set of teaching videos from entry to advanced. I will share with you my experience in using it in several chapters. What effects and advantages and disadvantages can the built-in fluid have? I will share with you my experience using this here. The version I am using now is 2000, 26.1.2. Then it added some new features. I customized the interface layout of the fluid. The next lesson will explain to you how to create your own set of work interfaces. For example, in the 2026 version, the launcher and type have been updated. The ones with yellow dots are highlighted reminders for updated content. Data mapper and liquid flow emitter are new emitters. Fluid fill emitter, it adds a fill direction ratio. Because the fluid function is a module function added starting from 2000, 25.3.1. Fluid filling in emitter types is highlighted. Description is new. Compare with 2000, 26.1 to see the difference. Explain the two versions side by side. On the right is version 2000, 25.3.1, and on the left is the latest version 2000, 26.1.2. The new version adds some new filling parameters, such as filling direction and proportion. The parameters will be explained in detail later. This is also a new launcher type. In version 2000, 25.3 only fill fluid. If you need continuous emitting fluid functionality like the basic emitter particles. Base emitter now rectangular, switch to circular. Click to play. The particle module is based on GPU calculation, so there seems to be no response when I play it. It is actually the preparation stage. Don't worry about the operating logic behind it. Now particles are not fluids. Increase the number of particles. Set the transmitter smaller 20. 2000, 25.3. The effect of fluid impact that needs to be done is that there is no such launch type fluid. Navigation uses object mode here. The wall collision body is smaller. There is a collision body label here in simulation. Nothing happens now. Because it is still a particle collision, it is not recognized by default. If you have experience using particle modules, you will know what the problem is. Requires collision modifier. You need to assign it to the group. Seems to work. But why doesn't it seem to have a rebound effect? Is it because the collision body does not have enough polygons? Change XY to 100 respectively. It still doesn't seem to work. Check switch on contact. It actually worked. Modify project timeframe. Switch on contact is to switch the particle group when colliding. Switch to another group and set the color of the particle group. Or switch its display type. Change the particles to pink for convenient and intuitive display. This is the most basic operation about particle groups. It's still a particle now rather than a fluid. There is the liquefy modifier in the type list. Click to add to scene object. These particles become liquid. Why is it exploding now? It's because the particles are too large by default. Enable the function of changing the display particle draw size. When the radius is displayed, you can understand why it exploded. Then you need to set Ctrl-D in the project. In the Solve Panel Bar Fluids panel. Then the default radius is 3 km, change it to 0 km. The smaller the value, the higher the simulation accuracy of the fluid. Now the liquid won't explode. This is how to implement a fluid emitter in version 2000, 25.3.1. The demonstration started with the particle collision function and then expanded to the implementation of the fluid emitter. If you just want a fluid emitter, you only need a particle group and a liquid modifier. It will automatically identify the collision of objects. Particles need to manually add a collision environment. Basic method of implementing fluid emitter in version 2000, 25.3.1. Switch to version 2000, 26.1. Liquid flow emitter is the fluid emitter by default. Recreate a collider. The collision body must be set to a uniform polygon. Otherwise, there may be problems with collision accuracy. Select the cube and add the collider label directly. It has a preparation stage. Compared with the 2025 version, it is relatively simple. Launcher speed increased. Change the size of its launch. Achieve the effect of fluid emission with just 2 clicks. The accuracy of fluid is the same operation as explained before. The default radius of the project is changed to O-neck. Fluid, the accuracy is improved. This is a brief explanation of the new fluid emitter in 2000, 26.1. Finally, the fluid filling function is explained. Create a ground. Create a cube. The proportions of objects should strictly follow the dimensions of real objects. 20*20. Cube as filled object. Select cube object. Then click on the fluid to fill the emitter. Duplicate a cube object, hide another. Shift+C search. Show label. Then display it in wireframe form. Let's make it a little wider. For example, it is 22*22. As a collision object, add a collision label. Select the back surface as the collision surface. Cancel wireframe display and change to box. Modify project time 200 frames. Then let's play it and see. Why is there no particle fluid now? Didn't we change the filling object to 20 cm? By default it is 3 cm. The default parameters are definitely not suitable for the current scene ratio and should be changed to 0.5 cm. The direction of the collider label is reversed and changed to internal. The scene now has fill fluid. Modify the color of the ground to facilitate our observation. Filling fluid will now cause jitter. Fluid parameter panel modifies neighbor access and additional iterations. The default radius is changed to 0.3 cm. It seems that after modifying the parameters, there will be no jitter. Activate gravity using time condition event. Set the gravity of the Control D project to 0. Add gravity. Greater than or equal to 1 or 2. Add gravity to the fluid in the first or second frame. Replay the timeline to observe the simulation effect. Why does some liquid leak from around the collision body? Maybe it doesn't have enough polygon segments. Select the object and re-add the subdivision surface. Change to Open Subdivision. Move the collision label to the subdivision surface to generate objects. Re-simulate viewing effects. Doesn't seem to have any effect. Do not select surface and change it to volume. Now the fluid won't leak out. Fluid-filled objects resize again. The padding in the 2025.3 version does not have parameters such as proportion settings. 2026.1 filling fluid parameters have added proportion and axial direction. For example, the y-axis is 100% if you don't fill it with fluid. Just fill half of the fluid and change the ratio to 50%. It fills the y-axis. You can now accurately achieve half-filled fluid effects. For example, you can fill his z-axis. OK. This is the new function of fluid filling in 2026.1. It can be filled proportionally according to the axial direction. The above is a simple explanation video sharing of the 2026.1 fluid function update. A simple comparison explains the functional differences of the update. And share some details that need to be paid attention to in fluid production. Today, I will make a simple comparison and introduction to the fluid update of the 2026.1 version. Some differences between the old and new versions and updates. In this lesson, we will first talk about sharing and end here. See you next time. Goodbye.